Let's now take a closer look at the exponential and logarithmic functions when using complex numbers. First, let's prove that e to the log of z is equal to z. We recall that if z is equal to r times cosine theta plus I sine theta, and theta is in a certain range uh, between negative pi and plus pi, with equality on the plus pi, then we define the log of z to be equal to the natural log of r plus I theta. So that's the definition of the logarithm of a complex number. So first off, let's prove that the log of e to the z, e to the log of z is equal to z. So proof of 1. E to the log of z, by the definition in red, is equal to e to the natural log of r plus I theta. So that's equal to e to the natural log r times e to the I theta. Well, e to the natural log r, because r is a real number, e to the natural log r is certainly equal to r. And by definition, e to the I theta is cosine theta plus I sine theta. And you'll notice that this last term in green matches what we have up here in red, and so that is equal to z. So if you take a complex number, apply the logarithm, and then e to that logarithm, you get the original number back. So that's number 1. For number 2, provide an example where this fails. Let's take a look at the log of e to the 2 pi I. So that's equal to the logarithm of cosine 2 pi plus I sine 2 pi and cosine 2 pi is 1, sine of 2 pi is 0, so that's going to be the logarithm of 1 base e, and so that's just simply going to be equal to 0. And notice that is not equal to 2 pi I. Now, why does this happen? This happens because the logarithm function has a restricted domain. The imaginary part that comes out must be between negative pi and plus pi. And so if my input has an imaginary part that is not between negative pi and plus pi, then there's no way for the logarithm of something to have an imaginary part between negative pi and plus pi. So because of this restricted domain, it is possible to generate counterexamples in this direction. So it is perfectly possible for the log of e to the z to be not equal to z if z is a complex number. However, the other direction, e to the log z, is always going to be equal to z.